Welcome back to the lecture on Archaea. Archaea is going to be a short section here, but we want to know about them because they are a major class of prokaryotes. Unfortunately for them, they don't cause disease in humans or any other kind of animal that we know of, so we don't really study them a whole lot in microbiology. Um, but that is good news for us. But because of the fact of where they live and their unique biochemistries that they must have in order to live in those places, they are definitely a topic worth studying for. For instance, if we want to know how to have better salt tolerance in plants, we might look at the bacteria growing in the Great Salt Lake and how they deal with the high um, salt pressures that they encounter. All right, so remember, it's all about the cell wall in our prokaryotes. Okay, we want to know about the cell wall. What's going to happen in the cell wall? And we even want to know that in our fungi. All right, so in Archaea, they don't have any true peptidoglycan. They have some kind of branched hydrocarbon chains, just like peptidoglycan, but it's not peptidoglycan. Okay, and they can produce by binary fission, like we talked about, and by budding. They can also reproduce by a thing called fragmentation, but we won't get into that too much. They can also have the same shapes, cocci, bacilli, spirals, and even be pleomorphic. So you can't quite tell based on their appearance alone. However, they do not cause disease, and this is a good thing. Okay, so Archaea can be sampled from the human body. We've found some in our mouth and other locations. Again, it's just not pathogenic. The reason why I mention that it can be in our body is that it's often easy to just think of them as extremophiles, okay, or creatures that love the extremes, and the extremes being high salt, high heat, high anything that usually kills other creatures. Okay, those would be extremophiles. Okay, so whenever you see this term phile, just like hydrophobic and hydrophilic, that's the same term. Um, they would be hydrophiles or hydrophobes. Um, Phile means that they love what they're in. So thermophiles would love heat, and halophiles love salt. If we look up the term thermo, that's going to mean heat, and that's where we get thermometer from. Halo um, is also means salt, and the ring of salt is where we get the term halo for the like angels even. So yeah, interesting to look up. So if you live in extreme heat, you are a thermophile. If you live in extreme salt, you are a halophile. And what that means is you can draw a graph and you can put salt on the bottom, the increasing amount of salt on the bottom, and you can say amount of creatures, so happiness, if you will, on the y-axis. Most creatures live somewhere here in a normal amount of salt. These creatures here would live here. Okay, they love the salt, right? So their salt content is low here and high here. Okay, the same graph can be drawn up here. Happiness and temperature. Most things want to live here. These guys in these vents would live here at a high temperature. They're here. Okay, and then we do even have some creatures that can live in the fridge, and they are psychrophiles. We'll learn about those, and you will want to know that term, psychrophiles. I like to kind of transmute it in my head to cryophile. Um, Cryophile, like cryogenics, kind of means cold. So psychrophile, cryophile, they like the cold, they are here. In our examples here we see extreme heat and extreme salt. So they like high salt, they like high temperatures. And this is very true for our friends Archaea. Um, and this is where we find them, and these are the interesting ones. But we can also find other types of bacteria who like higher salt concentrations. We can find other types of bacteria who do like the fridge. Okay, um, and Archaea can be organized into deeply branching bacteria or into phototropic bacteria. And if they are deeply branching bacteria, scientists believe they are similar to the earliest bacteria, and they live in habitats similar to the ones found on Earth. Okay. And there's also phototropic bacteria. These are purple sulfur bacteria, and have a few other groups that you would be interested in if you were going into further microbiology. But right now, we just need to know that the phototrophic kind of bacteria can make their own food because they are photosynthetic. Okay, and that is known as autotrophy, or they are known as autotrophic organisms. Auto meaning self, troph meaning what you're going to eat. Okay, so you can make your own food, and they use a different pigment as their source of energy. Okay, when we say source of electrons, we mean energy, and we'll get into that with our metabolism lecture pretty much next week. And so with that, we'll end our Archaea and other types of bacteria recording.